All right, welcome everyone. In this example, it's problem 421 in your textbook. It deals with throwing darts towards a dartboard, trying to hit the bullseye, but not quite. Right? So here's the problem. You throw a dart at 10 meters per second directly horizontally, initially directly horizontally. It takes 0.19 seconds to reach the dartboard, right, from the point after release, and it drops down a distance PQ, right, or a distance Y PQ. Okay, we want to find three things. We want to find that distance Y, we want to find the horizontal distance D to the dartboard, and we want to find the final speed or the velocity once it hits the dartboard at point Q. Okay, and that's what I failed to mention earlier. It arcs down and hits at point Q. Something like that. Okay? All right, so we'll call it part A, right? Um, in these problems, up until now, you may or may not have noticed a pattern with which you solve it, right? There are always four steps, right? The first one is to visualize the problem. And so I've done that by drawing just a simple sketch right here. The second is to strategize, right? Come up with a game plan or maybe something to try out, and then we'll see what and then we'll see if it works, right? Strategize how you might need to solve the problem. That could include writing down what you know and what you don't know, right? Two different columns. Um, it could include, you know, writing down entire kinematic equations, right? It whatever you think you might need, strategize how to go about attacking this problem. Okay. Thirdly, is to actually calculate it, right? Do your calculations and see if you get an answer. Once you get an answer, lastly, you should evaluate your answer to see if it makes sense, right? Just from a cursory perspective, just to see if it's in the ballpark. So for part A, the strategy here is to see that it's going to arc downwards. Okay. We should also note which direction is positive in this case. So I'm going to put up and right as the positive x and positive y directions, and I'm going to note that downwards is our acceleration, right? It has a value of minus g. All right, so in order to find the distance that this dart falls in that time, we know time, that's good. Well, we need an equation, one in the y direction. I guess it doesn't have to be. Yeah, we're finding the y distance, that's silly for them. We need an equation in the y direction that includes time and includes, well, that, right? A final height. So one that pops into mind is, let's see, this one. Y equals y naught plus v naught yt minus 1 half gt squared. Will this give us what we want? Let's see, what do we know? In this equation, we know that initially we can start at a height of, say, well, tell you what, this y naught here and y, that's a relative change in height, right? This here, this final height is actually y minus y naught, right? It's actually the change in height. So that's another piece of the strategize puzzle, to recognize that, at least in this case, when you want to find the final height, that means the final height from which it started. Okay? And so what I've written here is the same thing as if you were to set y naught equals 0. Okay? So the initial speed in the y direction, well, what's that? If it was released purely horizontally, which I believe I stated it did, If I didn't, I apologize. It does start out initially horizontally. That's what the problem states. Okay. So that means that this second term here is 0. Okay. And so our equation boils down to, on the right side, negative 1/2 g times time squared. And so if we want to put the y naught to be 0, right, we're starting from a relative height of 0 and we just want to find the final change in height. Well, there we go. Negative 0, or sorry, negative 1/2, 9.81 times our 0.19 squared. And for this, we should get a value of, well, where is it? 0.18 meters. The negative should make sense because I've specified up to be positive, and this dart falls down, right? So the negative makes sense. The number, it's a pretty small number compared to how quickly it's going, so keep that in mind. So this is our answer for part A. Put a box around it. Part B, or rather the horizontal distance D, the strategy here is to realize that the horizontal component of the dart's speed will not change. So in other words, it'll continue at 10 meters per second horizontally until it strikes the surface, until it strikes the dartboard, all right, after passing a distance d. Assuming, of course, that it's traveling fast enough to do that, which it is. So in that case, we need an equation in the x direction. So our go-to should be this one. X equals x naught plus v naught x times time. We know time. We know v naught x. Excuse me. And we're trying to find this unknown distance d, which is really x minus x naught, right? Because again, like in part A, we can assume that the initial starting position is really just 0. We're only interested in the relative change. So x is the same thing as d here. And so that equals, well, v naught x times t, and so that's just 10 times our 0.19, which is our 1.9 seconds. Okay. All right, and so the third part here, finding the final speed. This will be a little more tricky, but not too much, right? The final speed v. Tell you what, let's find the final velocity. Let's make that a vector, right? We can do that. If you think about it, in part B, we already found one of the components, right? The initial velocity in the x direction will be the same as the final velocity in the x direction. Horizontally, it doesn't change. So we can write in v naught x equals vx, right? The final speed, they're the same. Vertically, that speed will change, right? There's a force in the vertical direction. So how can we find vy in this case? We need an equation with vy in it. And the one that comes to mind is the one that's squared. So vy squared equals v naught y squared minus 2g times delta y. Okay? And what cancels out here, right? V naught y, well, it's 0. Starting out initially horizontally, so that is 0. Let's see, y naught, we said was 0 earlier. And so Vy, our final vertical speed, is the square root of minus 2gy. I guess I don't need all that. There you go. So let's hope that this g times y product is a negative to cancel out the negative in there. Otherwise, math will yell at us. So let's see. Minus 2g, we've already put in the minus sign, so don't do it again here. The y, right, the final vertical height, from our part A, that's where the negative sign comes from to cancel out the other one. Okay, so now we can take the square root without math exploding, and we should get a value of, checking my notes, 1.88 meters per second. Okay, and so we have that component. I failed to write down the actual value. We have the x component. Now find v. So we have 10 squared plus 1.88 squared square root, and we should get 10 point, what did I get earlier? 10.18 meters per second as the final speed, right? Does this make sense? Right? This magnitude is just a little bit greater, just a little bit faster than the initial speed. Right? The initial speed was 10, but it was only horizontally. Now, after a little bit of time, there's a little bit of a component downwards. Right? It's been accelerated downwards. So it's actually increased its overall velocity. So yes, that does make sense, 10.18. To make this a velocity, we need the angle. To do that, we need inverse tangent. I'm quickly running out of room. I'm going to draw it. Tell you what we have. I'm going to draw it on here. In colors, we have our regular V naught or Vx, and in red, our Vy. Right? So again, that's a right triangle. Something like that. And you are free to choose the angle, right? You'll get the correct answer regardless of which place you choose. If you choose the angle right there, that means inverse tangent is Vy over Vx. If you choose your angle here, inverse tangent is Vx over Vy. Excuse me. And so, I don't know, I'm going to choose down there. It doesn't matter. So that means that our inverse tangent is 10 divided by 0, what did I do? 1.88. Yep. And so our angle should be 10.65. It's really small. Right? Well, sorry. That's not 10.65. It's the complement because I'm silly. It should be about 79.4 or so, right? And that's 79.4 from negative y. Right? We'll say 79.4 counterclockwise from negative y, right? If you do it the other way, if you do the other angle, your angle should be 10.6 degrees, and that is clockwise from the x-axis, okay? But in essence, this is the final velocity, 10.18 meters per second at an angle of 79.4 degrees or so counterclockwise from minus y. All right. Thanks for watching.